Good afternoon. I hope you're all doing well. Again, tutorial test will close on Sunday at 2 o'clock. Make sure that you have done it at least once. The assignment is due for submission on Monday before 4 o'clock. So please make sure that you have submitted that before time. If you're done, there's no need to wait for the last minute. Just go ahead and submit it. Then we can start with the allocations, and you'll be notified when there's somebody for you to mark. Try and mark as correctly and as well as possible, because you are assessed on how well you are able to mark. So if you just give everybody 100%, that is going to be deducted from you in a way. So try and stick to the memo. All right, so today we continue with the sums, sequences, and series. We'll look at the sigma notation. Now, sigma is a Greek letter. Write it like this. It is used to denote a sum. So here we have k is equal to 1, and then n, and if we have something like this, ak. Right, now this k is equal to 1 over here. This tells you your starting point. And this tells you your ending point or your end point. Okay, so the values of k will go from 1, whatever your starting point is. It doesn't always have to be 1. Your starting point can be -5 or -1000. It doesn't matter. But then you have a sub 1, then plus, because it's a sum, a sub 2, a sub 3, and then you keep adding them until you get to a sub n, so whatever number you have over there. So the sigma notation is just a shorter way of writing this long sum over here. Now this sum here, which is a sum of a sequence, is what we call a series. So a sequence, you just list your numbers like that, and so on. But then with a series, what you do is you add the numbers. That is the only difference between a sequence and a series. A sequence, you just list all your numbers, they're separated by a comma. But in a series, you are adding all the terms in the sequence together. Okay, so we call k the index of summation. So we can look at an example. Here, let's say I have the sum k is equal to 1, and I'm going to stop at 11, and then I have k squared. So this k over here is the one that is going to go 1, 2, 3, 4, 5, and so on until I get to 11. So if I want to expand this, what I have is 1 squared, because the k, you substitute the starting point. Then the next number after 1 is 2, so I have 2 squared. Then after 2 squared, I have 3 squared, 4 squared, and then I keep going, and the last one I will write is 11 squared, my end point over there. Okay, so the k is the one that is changing. It starts at your starting point that is indicated over there, and you stop when you get to this value of k over there. So like I've done, you see what is happening to k? K is being squared. You have 1 squared, 2 squared. Okay, that's better. Right, so you have 1 squared, 2 squared, 3 squared, and you continue until you get to your endpoint over there. So the index is the one that is increasing until you get to your endpoint. So this is the long way of writing your summation, and then what I have over here is the shorter way, more condensed way of writing the summation. So we can look at another example. Here k is equal to -3 to 0 of 2k plus 1. So your k doesn't always have to start at 1. Your k can start anywhere actually. But the way it works is you must just keep adding 1. And your k has to be an integer because you're counting terms. Okay, so you cannot have a half term. So it must be an integer. So your starting point is for k equal to -3. Then the next one will be k equal to -2, k equal to -1, then k equal to 0 is your endpoint. So the number up here tells you where to stop. So if we expand this, the first term is the one where I have -3. Then remember, this summation means I'm summing them up. I'm not just listing them. So my terms are separated by a plus. So it's not comma, it is a series. Then the next one, I have 2, -2 plus 1. And then I add that to 2, -1 plus 1. And then I add that to 2 times 0 plus 1. I stop here because that is the value I have on top there. The value on top there tells me where I need to stop. This one here tells me where I start, and then I keep adding 1 until I get to the number on top there. So my number at the bottom, my starting index point, will always be less than where it is that I am going. So you can see the k, I started with -3. So everywhere you have k, you will substitute that value. Here I have k in only one place, but you may have other summations where k appears more than once in the expression. That means you still substitute k everywhere you see k, right? So -3, then -2, -1, and 0. And this, you work it out. The first one, 2 times -3 plus 1. This is -5. And then 2 times -2 plus 1. That is -3. 2 times -1 plus 1. That is -1. And then the last one, 2 times 0 plus 1. This is 1. So here it's a sum, should give you a single number, which is -8. Okay, so we can look at another one. Let's say we have k is equal to 0, then you go to 3, and here we have 2 to the power of k over k plus 1. Okay, so when we work this one out, we do it in exactly the same way. Now you'll notice what is different here is k appears in more than one place. There's a k over there, and there's a k over there as well. So for every k that I have, that's 0, 1, 2, and 3, I will substitute it there as well as over there. So this summation is just 2 to the power of 0 over 0 plus 1. Then I add that to 2 to the power of 1 over 1 plus 1. Then I add that to 2 to the power of 2 over 2 plus 2. And then I add that to 2 to the power of 3 over 3 plus 1. So you can see my k's there and there. I substitute the same k at every term. Here it's 1, there it's 1. There it's 2, and there it's 2, over there it's 3, and then over there it's 3. Then I would work it out in the same way. 2 to the power of 0 is 1, 1 over 1, this is 1. Then 2 to the power of 1 divided by 2, this is also equal to 1. And then the next one, I have 2 to the power of 2, which is 4. 4 divided by 4 is also 1. then the last term in my sequence 2 to the power of 3 is 8. 8 divided by 4, this is 2. So now I add these terms 1 plus 1 plus 1 plus 2. This is equal to 5. Yes?
The third term is not through the power 2 over 2 plus 1.
The which term?
Third.
The third term, this one here.
The denominator.
The plus 1. Yes, thank you. So that means I have 4 over 3. Thank you very much. Okay, let me write this better. Okay, so that is fine now. Then your sum will be different. This is 4 plus 4 over 3. That is 5 1/3. Okay, so then that is your sum. Okay, so everywhere you have k, you just substitute. You start with 0, then increase by 1 until you get to the number that you have on top there. So it's not always just going to be a linear expression. You may even have a quadratic expression. So this k is equal to minus 1, and you go to 2, and then I give you k squared plus 4k minus 2. Even this one, you can still do it in the same way. You start with k is negative 1, you get your answer, then you add that when k is 0, you get your answer, you add that when k is 1, and also when k is 2. So when you get to k is equal to 2, that is where you stop. Okay, so that is how the sigma notation works. Now when we have a sum, we can also write it in sigma notation. Let's say, for example, I have 1 plus 2 plus 4 plus 8 plus, so this continues until I get to 64. Now what we want to do is rewrite it. What we want to do is rewrite this in sigma notation. So I want to rewrite it using this. Now we did something similar to this in the last class where we rewrote it as we wrote down the formula for the nth term. So this one, if you remember, we say this is 2 to the power of n. Because if I look at the first term, I can rewrite it as 2 to the power of something, and the second one 2 to the power of something, and all the way up until 64. So I know over here the formula I will put is 2 to the power of, sorry, not n, I will put k because my index is k. And now can somebody tell me what is my starting point?
One is the starting point. 1.
Is 1 the starting point? Okay, if 1 is the starting point, she says we should put, this is 1, and what is my end point?
Infinity.
Infinity. It's not
Miss, I
infinity.
think as the starting point is 0.
Okay.
The starting point is 0.
Okay, so some people are saying the starting point is 0. What about the end point? She said infinity. Is that correct?
Oh, sorry, ma'am. I see
No.
now. I
What
see
is
now.
the end point?
64, miss.
The end point is 64. Is that correct?
No.
Yes.
No, it's not correct.
Okay, remember we're not looking at the endpoint as the value. K is what is happening over here, the exponent that we are going to
Miss, the
stop
end
at.
point is 8.
The endpoint is 8. Okay, so we
I think
said our
it's 6.
start point.
No, not 8. Not 8. 6.
Not 8.
It's
Is
6.
it 6?
Yes.
Okay,
6.
so somebody's saying the endpoint is 6. All right, now The reason the starting point is not 1 is because if I start with 1 there, you will see my first number is 2 to the power of 1. Then I have 2 to the power of 2, and then I continue up until 2 to the power of 6. And I have left out the very first number that was given to me in the series. Okay, so I do not leave out any of the numbers. So that is why my starting point has to be at 0. Then this 64, I will rewrite it as 2 to the power of 6. So 64, this is 2 to the power of 6. So I'm adding numbers starting from 2 to the power of 0, 2 to the power of 1, power 2, 3, 4, 5, and 6. So k goes from 0. So this 0 over here tells me what my starting point is. And the 6 over here
Miss, you
tells
forgot
me
to
what
start this
number.
2 to the power 0.
Excuse me?
You forgot to start this 2 to the power 0, Miss.
Where?
Miss, when you started listing the numbers.
I mean these numbers here. Is it these numbers you're talking about? Okay, because I can see 2 to the power of 0
Yes,
there.
Miss.
But 2 to the power of 0 is here. Can you see it?
Yes, Miss.
Okay, so it's there. The first time I wrote them, I didn't write that because I wanted to show you that the starting point cannot be 1. Because if k is 1, then the first number you are adding in the series is 2. And that means you will have left out this 1 here. And you have to add all the numbers that are given over there. Okay, so this is how we would shorten it. Let me just write it again. This is the sum. We start k is equal to 0. We end at 6. This is 2 to the power of k. So k will start 0, 1, 2, 3, 4, 5, and 6. And then we stop there. Then we add all those numbers together. Okay, let's look at another one. We have negative 2 plus 4 minus 6 plus 8 minus 10. So this is an example of an alternating series. It's alternating because the signs of the terms are changing. The first one is negative, then I get a positive one, then I get a negative, then a positive, and so on. So here I have 5 terms. So I can rewrite them as negative 2 plus 4 plus negative 6 plus 8 plus negative 10. So I can rewrite it like this so that you can see the sum, the plus is clear over there, that this is indeed a sum. I think we looked at this one as well in the last class. We gave a formula for the nth term. Somebody tell me what it is. Or you can guess, what do you think a formula for the nth term will be?
Negative 2 times n.
Negative 2 times n. Okay, he says maybe negative 2 times n. But when I look at this, if it's negative 2 times n, then all my terms should be negative, isn't it? If n is a positive number, then they'll all be negative. And if n is a negative number, they'll all be positive. But I'm alternating here. Some are positive and some are negative. So negative 2n, that's not right. But that's close. I think you can see the pattern. All these numbers are multiples of 2. How can we change that? I think we looked at some alternating sequences. There was always something that was present in our alternating sequence. What was that? What was always present was -1 to the power of n. So here, if I wanted to rewrite this as, or a formula for the nth term, I would say -1 to the power of n multiplied by 2 to the power of n. Now all these are multiples of 2, so that is represented in the 2n, and then this will take care of the alternating, because depending on your power of n, your value of n, then it'll either be positive or negative. So this is a formula for the nth term, but now I want to rewrite it so that I have k. So I have k, where am I starting from, and what do I write over here? Can somebody tell me what is the starting point?
Starting point is 1, miss.
Okay, she says the starting point is 1, and what is the end point?
It's 5.
Okay, she says the end point is 5. Then what formula am I going to put over there?
The formula of -1 to the power n times 2n.
Okay, she says this. Is this correct? What is
Yes.
wrong? What is wrong with what I have written there?
Miss, I think you must replace the N with a K.
With the k, exactly. This formula has to be in terms of k, because if I rewrite it the way it, if I just leave it the way it is, k has no effect on this formula. So I need to see k instead of n. So what you should change is this. So you should have to the power of k, and then to k over there. And then k will start at 1, so this will be negative, and then 2 times 1 is just 2, you'll get -2. Then you add that when k is 2, the -1 will be +1, and then this will be 4. Okay, so it's important that when you rewrite it in summation or in sigma notation, that k has to be present, not n, because otherwise k has no effect. Right, let's look at one more. Say we have x plus x squared over 2 plus x to the power of 3 over 3 plus x to the power of 4 over 4, and then this one just has dots like that. How would we write this in sigma notation? So with this, what you need to figure out, what is increasing, which one is the one that is going from something, then you add 1 to it, then you add 2 to it. That is the one that is going to be your k. So you look at what is increasing from one term to another. If it's going in those steps, 1, you add another 1, you add another 1. That should be your k. So you know that the sigma should be there. Can somebody tell me what my starting point is?
Zero means
0. Okay, she says 0. And what is my end point?
That is
there's no end.
infinity.
It's infinity.
Sorry,
Right?
it is infinity.
Not
Infinity.
infinity.
The end point is infinity. That means you just keep adding. You just keep adding. Okay, so the end point is correct, but the starting point is not. So this starting point over here is not correct. Okay, so we can leave it for now. We'll come back to it. Can we come up with a formula that we should put over here? What do you think should go over there? So you need to tell me what is increasing. What do you see that's going from, you keep adding 1 to it? That should be your k.
Miss,
Yes,
I think the formula should be 1 to the power k over k plus 1.
1 to the power of k over k plus 1.
K plus 1.
K plus 1. Hmm.
Yes, miss.
I think here your numerator will always be 1 because 1 to the power of um, anything is just 1. And then in your denominator, okay, it may work, but when I look at this, I see that my exponent and my denominator are always the same. But when I look at yours, I see they are not the same. So it's like maybe at one point I'll have this over 3, which doesn't fit in what I have over there. So I don't think that's right. So it's a good try. You can see what is increasing, but not quite. Somebody else want to try?
Miss,
Yes.
I think that it's x to the power of k over
Okay.
k or something like that.
Okay, that is very good. So the k is constant. That one does not change. K may be 1, but we are not told what k is. And if you look at this, the first term is x to the power of 1 over 1. So this exponent is the one that is increasing by 1 each time. So you add 1, you get 2. You add 1, you get 3. You add 1, you get 3. So that should be represented by a k. And then the denominator as well. You start at 1, then 2, then 3, then 4, and they keep increasing in that manner. Okay? Okay, and then your denominator as well. It keeps increasing. You start at 1, then 2, then 3, then 4, and so on. Okay, and then so we said that because we just keep adding terms, we don't have a stopping or an end point. That means our end point is infinity. So we'll never actually get there. We'll just keep adding forever. But now what is my starting point? Because we left that out at the beginning.
Is it at 1?
Yes, it is 1. Okay, so this is how you would write this series in a condensed form using the sigma notation. So always look at what is increasing, and then you replace that with k. Okay, so that is how to write in sigma notation. Now we go into two specific sequences and series. The first one is the arithmetic sequence. Now this arithmetic sequence is very simple. An example of an arithmetic sequence is this one here: 1, 2, 3, 4, 5, and then it goes on. I'm sure if I asked you to guess, you'd be able to tell me that the next number after 5 is 6. I could ask you what is the 10th number in the sequence. You'll tell me it's 10, and so on. Now what makes a sequence arithmetic is the fact that if I want to work out the next term, if I have a starting term and I want to work out the next one, all I have to do is add a specific number. You will notice that any two consecutive terms have a common difference. So if I say 2 minus 1, the answer is 1. 3 minus 1, the answer is, 3 minus 2, the answer is 1. 4 minus 3, the answer is 1. 5 minus 4, the answer is 1. So any two consecutive terms, consecutive means they follow each other. The difference between the term numbers is 1. So if I subtract the one that comes later, I subtract the one that comes right before it, the difference is always the same. That's what makes a sequence arithmetic. If when I work out the difference there, it's 2, the difference there is 3, and there it's 4, or it's not even, there isn't even a pattern in the difference, that is not arithmetic. With arithmetic, you must have a common difference. Okay, so any two consecutive terms, you take an plus 1, you subtract an, the answer is equal to d. So if I have a2 minus a1, this will give me d. A100 minus a99, this should give me d. So that is the definition of an arithmetic sequence. So if I have a99 and I want to get 100, I just add d to that, and then this will give me the 100th term. Okay, so with an arithmetic sequence, the general formula. So the general formula of an arithmetic sequence, or the nth term, is given by this an. This is equal to a1, which is the first term, plus n minus 1 times d. Okay, so that is the general formula. So if I want to work out the nth term, I need to use the first term and the common difference, then substitute whatever n I'm looking for into the formula, and then that will tell me what the nth term is. So if we look at the simplest one we have, which is 1, 2, 3, 4, and so on, we can write down the formula, or we can write down the formula for the nth term. So this an, this is just equal to a1 over here. A1 is always the first term in the sequence, which is 1 plus n minus 1. And then my common difference, I said 2 minus 1, which is 1. So this is what I have. So here my an is given by 1 plus, the 1 should multiply in there. So I have n minus 1, and this is just equal to n. So the nth term in the sequence is just n. So if I want to work out the 7th term, this is just 7. I substitute 7. If I want the 1000th term, this is just 1000. And I'm sure with that one you can easily figure out because this is just the counting numbers. Okay, you can look at another one. Let's say we have 4, 9, 14, 19, 24, and then it continues in this way. Now you can always check to make sure that this is indeed an arithmetic sequence. You say 9 minus 4, this is 5. 14 minus 9, this is 5. 19 minus 14, this is 5. 24 minus 19, this is equal to 5. So I do have a common difference here. So this is indeed arithmetic. So if I want to work out the formula for AN, I know in general AN is given by A sub 1 plus N minus 1 times D. So my D is over here. I can see it's the same. And A1 is just the first term, and you can see it. There it is. It is given to you. So A1 is equal to 4 and D is equal to 5. I will substitute them over there. So in general, AN is 4 plus N minus 1 times D, which is equal to 5. Then I can multiply this out to simplify it. This is 4 plus 5N minus 5. This AN is just 5N minus 1. And then I can always test it to see if it does in fact work. I have the first 1, 2, 3, 4, 5 terms. I can substitute n equal to 1 to 5 into this equation and see that do I really get back the sequence that I was given. So here, this is me just testing it out. If I want A1, this is 5 times 1 minus 1. 5 times 1 is 5 minus 1. This is 4, and that is the first term in our sequence. What if I want the second one? This is 5 times 2 minus 1. This is 10 minus 1, which is 9. And then when we look at our sequence, yes, 9 is in fact the second one. Now let's look at the fifth term. Let's see. This is 5 times 5 minus 1, which is 25 minus 1. This is 24. And when you look at your sequence, you can see that the fifth term is indeed 25. So this formula for the nth term that I have given is in fact correct. So you can also use it to work out terms that are further away, because with the first 3 or 4 terms it's easy to list them. But what if I want the 30th term? Okay, listing 30 of them might not be as easy. So what I do is I just substitute. This is 5 times 30 minus 1. 5 times 30 is 150. Then 150 minus 1 is 149. And you can check by listing all the terms up to 30 terms. You will see that the 30th term is in fact 149. Okay. Then let's look at another example. Let's say I give you another sequence. I say 4, 7, 10, and 13, and it continues in this way. I tell you that this is an arithmetic sequence, so we will mainly focus on the arithmetic and the geometric. With arithmetic, there is a common difference. Any two terms, when you subtract them, 7 minus 4, you get 3. 10 minus 7, you get 3. 13 minus 10, you get 3. So this is in fact an arithmetic progression or an arithmetic sequence. Now, sometimes the questions are not just to find the nth term. I could also give you a term. Let's say I tell you that 301 is a term in the sequence. What number is it? What term number is it? Okay, so that means I have listed all the numbers and I see 301 is in the sequence. So you have to tell me what number it comes in the sequence. So this is a little like working backwards, but this time what we are trying to do is work out the value of n. So we know what the nth term is. So we know that an is equal to 301. Now the question is, what is the value of n? So we would do it in pretty much the same way. We can come up with a formula for the nth term, and then we equate that to 301, and then we solve for n. So we know that in general, an, this is given by a sub 1 plus n minus 1 times d. So d we already worked out. We say that d is equal to 3. It's the common difference. Any two consecutive terms, you work out the one on the right minus the one on the left. So this was our d. So I will substitute. an is 301. There it's given to us. a1, the first term in the sequence, if you look at it, it's 4. And then I have n minus 1. And then my common difference is 3. So n is what I am trying to work out, because I want to find out what number does 301 come in the sequence. So to solve this, I have 3n minus 1 plus 4. This is equal to 301. I've just rewritten the equation. I will subtract 4 on both sides. So I have 3n minus 1. This is equal to 297. And then I will divide by 3 on both sides. N minus 1. This is equal to 99. And then I will add 1 on both sides. So I have n is equal to 100. So this means that the 100th term in the sequence is 301. So 301 is the 100th term in the sequence. Okay, so we can work in both directions. I give you the terms in the sequence, I list them. I ask you to find the nth term, or I ask you to work out what number a given term appears in the sequence. So let's look at some more examples of this. Let's say I give you a sequence 0.07, 0.12, 0.17, and then 0.22, and it continues in this way. So this is an arithmetic progression, an arithmetic sequence. The common difference between them is 0.05. So you take any two consecutive terms, you say the one on the right minus the one on the left. So we can work out d. This is 0.17 minus 0.12. This is 0.05. So it doesn't have to be the first and the second that you use to work out d, because d is constant. Any two terms that follow each other, if you say the one on the right minus the one on the left, that will give you d. So I have my d, my a. I just look at the sequence. There it is. This is 0.07. Okay, now with this sequence, I'm asked to work out the general formula for the nth term, find the 11th term, and then I'm asked what term number is 1.67. So there's 3 questions. The first one is find a formula for the nth term. Okay, now the formula for the nth term, we know this is just an. For any arithmetic progression, this is just then times d. A1, which is the one that is given in the question there, 0.07. I'll write this is 0.07, and then I have n minus 1. My common difference, this is 0.05. Okay, so I can rewrite this so that it is as simplified as possible. So what I will have is an, this is 0.07 plus 0.05n minus 0.05. Then when I simplify this, I have an, this is 0.05n plus 0.02. So these two are like terms, so I can combine them and then I get 0.02. So that was the first part of the question. Find the formula for the nth term. Then the second part of the question, number 2, was to find the 11th term. So I'm looking for a sub 11. So everywhere I have n, I am going to substitute 11 and simplify that to get my answer. So this is just 0.05 times 11 plus 0.02. Okay, this you can do on your calculator, but even without, it's not too difficult. 0.05 times 11 should be 0.55, and then you add 0.02, you should get 0.57 as your 11th term. And then the last part of this question, we are given an is 1.67. So I give you a term, then I ask you what number does this term come in the sequence. So now we're looking for n. That's what we want to work out. So here we know the general formula for the nth term is this one that we just worked out over here, 0.05n plus 0.02. So we know that an, this is 0.05n plus 0.02. And we have our an, which is 1.67, so we will substitute that over there. So doing that, I have 1.67. This is equal to 0.05n plus 0.02. So this is an equation where you must solve for n. So everything with n on one side, everything without n on the other side. We're left with 0.05n. This is equal to 1.65 minus 0.65. So I have 1.65. Then I will divide 1.65 by 0.05. So I have n 1.65. Divide this by 0.05. And here I get n is equal to 33. So here we can then conclude that 1.67 is the 33rd term in the sequence. Okay, and that's it. Okay, so with these arithmetic sequences, we will not just stop at finding the nth term, the formula, and what number a term comes in the sequence. I could also ask you to add up to a certain number of terms in the sequence. So you have a sequence, and then I say find the sum of the first n terms. Now the general formula for the sum of the first n terms, we write it like this. This is S for sum of the first n terms. This is n over 2, and then I multiply this by the sum of a1 plus an. Okay, so this means that if you know the first term and you know the nth term that you're adding up to, you can add those two together and then you multiply that by n divided by 2. Another formula that we use, we have Sn. This is equal to n over 2 times a1 plus n minus 1 times d. You can use either of these formulas to get your sum of the first n terms. It is really up to you. If you know what the last term in the sequence is, let's say for example it is given, then it's very easy to use the first one, and otherwise you can use the second one. So it's really up to you. So one such a question could be find the sum of the first 50 positive integers. Okay, so we want to find the sum of the first 50 positive integers. So you start with 1, you add 2, then 3, then 4, up until you get to 50. Doing it that way, where I'm 1 plus 2 plus 3 plus what, until I get to 50 is going to take me quite a long time. But if you realize that the integers form an arithmetic progression, then you can just use this formula to work out the sum of the first 50, even the first 1 million integers. So I know that I can list the first few positive integers like this: 1, 2, 3, 4, and I go on up until I get to 50. Now this is indeed an arithmetic progression because the difference between any two consecutive terms is 1. So 2 minus 1, that is 1, that is 1, and so on. So I want to work out what is the sum of all of these. So I'm asking what is 1 plus 2 plus 3 plus 4 plus so on up until I get to 50. So what I can do is, I know what a is. My a1, this is equal to 1. My common difference, this is equal to 1 as well. Then I can just use my formula. So I know that Sn, n here is 50 because I'm working out the sum of the first 50 integers. And this is equal to n, which is 50 divided by 2. And then I multiply 2 by a1. And then I add n, which is 50 minus 1 times the common difference, which is 1. Then I close my bracket. Okay, so you can do this. This is 25. Inside my bracket I have 2 plus 49. This is 25 multiplied by 51. So do this on your calculator. 25, you get 1,275. And you can actually try it 1 plus 2 plus 3 plus 4 and so on up until you get to 50. You will see that the sum is exactly equal to 1,275. And this took me like a minute adding them one by one like that will take you quite a long time. So you can use the other formula as well, because here you know what your 50th term is. You know that you have 50 terms. The last term is 50. You can use that one as well. So as 50, this is equal to 50 divided by 2. And then inside the bracket, we said A1, which is 1. And then I add that to the last term, which is 50 itself. So here I'm using the second formula. This is A1. This is AN, which is the 50th term. So here you'll see I get 25 times 51, which is exactly what I have there. Then the product is still 1,275. So whichever of the formulas you use, the answer will be exactly the same. Okay, so I will stop there for today. Do we have any questions before we go?
Yes, Miss, I have a question
Yeah.
regarding the assignment.
Yes.
In which order should we capture the assignment?
Excuse me?
Will we capture like the graph first or the answers first?
I would say you, I think, follow the order that is given in the notes, because I would think you would put your constraints, do some working, your graph, and then the solutions from the graph afterwards. That's how I would look at it. But if you submitted and you put them in with the graph at the end, let's hope the person marking you will be kind. And since you're marking each other, if the person has written the answers, the order shouldn't be the reason why you mark them wrong. Okay, so try and put them in the order that you are working them out. So if you did the graph and then used the graph to work out the solutions, I would have the graph before the solutions.
Okay, Miss.
Okay, any other questions, or are we good? Okay, so I will see you guys tomorrow, or I will hear you guys tomorrow, 9:30. Have a good day. Please remember to upload your assignment. Since you guys are the ones marking, I'm sure you will not accept any late submissions. Okay, so have a good day.